Okay then, Petter, it's a minute past. The session is being recorded. Welcome to session 4K, Unit Testing Reimagined from a developer perspective with Petter Vakula. Petter, I will keep an eye on the questions, as I mentioned. If any attendees want to ask questions, please put them in the chat, and Petter will take them as they come up rather than wait until the end. So, Petter, over to you. Good luck.
Perfect. Thank you very much, Stuart. So thank you very much for joining this session. Happy to be here. And as Stuart mentioned, we'll be looking at unit testing today. And we will take a look at how we can reimagine the unit testing being done on a mainframe from a perspective of a developer. So hopefully this would be kind of informative session. I don't intend to fill in the whole hour. So if you would have any questions, feel free to post them into the chat. And you can even try to unmute yourself and ask and interrupt. I don't have a problem with that. My name is Petr Vacula. I'm with Broadcom, and I'm in our mainframe software division, responsible for our testing tool solutions as a product manager. With that, let's start, and let's start with some level set. What unit testing is, and check that we are on the same page. What is the goal of unit testing? And here I'll be talking about really generally. This is not specific to mainframe. This is really generally talking about unit testing. So goal of a unit testing is to enable sustainable growth of a software project. What does it really mean? So when you start your project and you are maturing, adding more modules, adding more lines of codes, managing that project becomes a little bit harder. So essentially introducing new change or fixing some old behavior is very time consuming unless you have a good set and safety network of unit tests. So if you took the initial effort in writing your safety network of unit tests, introducing a new change, putting a new behavior into the code base is far much more easier if you have the unit tests. Generally speaking, this goal is essentially applicable to any tests, any types of tests, but I think it's very paramount for unit testing itself, which is essentially the foundation base for your test automation. Now let's take a look at the definition and what are the key characteristics of a unit test case. Number one unit test case is a automated test. And I need to stress out the automated because sometimes people either take it as a granted or might overlook that. You really want to make sure that the unit tests are automatable. So you can run them as part of your pipeline. So you do not need to redo things manually or semi-manually. This is a very key aspect to keep in mind and not just to take it as a granted. And then the three key characteristics of a unit test case is that it verifies a small piece of code. Here, I think we can have a debate on what is small enough. In the world of mainframe, and specifically looking at COBOL, the small piece is not a load module. The small piece is probably not a CSECT. We should be talking here about at least sections or paragraphs in the COBOL world. The second characteristic of a unit test case is that it does the testing quickly. And again, it depends on your project. What quickly means for you is like 10 minutes quickly enough, is 2 seconds quickly enough. I would just like comment in here that you as a developer or developing your code, you want to get that feedback preferably instantly, right? So I'm writing my code, writing, and now I want to do this quick check that I haven't break anything and the code is still working, and preferably I also write some test cases of my new code so I can quickly validate that the code works properly. So I can get that feedback instantly, and I do not need to wait days, weeks before some big batch testing is being scheduled. So I will be notified 2 months later, hey, you have a problem in your code, you need to go back and fix it. I no longer remember what that was that I was fixing. The last characteristic is the most problematic from these three. And it says that the unit test case does its job in an isolated manner. There are two main point of views on what the isolation means for unit test cases. And the more strict one takes a look at it that the system under test, so essentially the piece of code that you are testing, needs to be isolated from all its collaborators. What does it mean? So if your program or if the paragraph is calling a different module, different paragraph, you need to double. So essentially, you need to provide mocks for those called routines, and this way you will ensure that you are only testing and focusing on the system under test or on the paragraph that you want to test. This can be sometimes a little bit tricky to get into this level of isolation. So the second point of view on the isolation is that you want to run your test cases in an isolated manner. What this means is that you can run your test cases concurrently. So the test cases are not interfering with each other. So essentially, as part of your testing, you can be focusing on the one paragraph, and if that paragraph is calling another routine or calling another program, you can still do that as long as the system under test is not leveraging some shared resources, like doing something in a shared memory or accessing shared data. Because in this instance, it would not be, the test cases would not be isolated. So if you run two test cases that do the same thing, accessing the same shared resource, you would immediately run into collisions. The definitions of the unit tests and the goal of unit tests is not something that I came up with. It's written in this perfect book, Unit Testing Principles, Practices, and Patterns from Vladimir Korykov. I recommend to read it if you haven't look into it yet. I actually even use it as a reference. So if I need to refer back to something, it's a very good book to use, and I recommend looking into it. Now, let's move ahead a little bit. So how a unit test case can look like. This is a Java code, and I'm sorry if you don't know Java. I'll try to walk you through that code, but hopefully this should be pretty straightforward to read through that. Similarly, as it's straightforward to read COBOL code, right? So on the left, you see a Java class with its methods, and this is the system under test that we want to test. And on the right side, you see a test case that was written. This example I took from the JUnit for getting started. I haven't took the latest one from JUnit 5 because I think this example illustrates the unit testing technique slightly better than the new, where you have only a unit test case and not the system under test. So let's take a look at the system on the class that we are going to test. So we have a class. It's a calculator. It has only one method, and that method takes a string. That string is expected to be in a format of numbers divided by plus sign, and essentially the method does that. It parses that, and it returns the sum of all the numbers that were found in between those plus signs. Now, how to test it? In JUnit world and in Java world, you write another class. So this is the test class with one method, and that method essentially instantiates the system under test, the calculator. It provides some input data. In this case, the string is 1 + 2 + 3, and the expectation would be that if we call this method, the return number would be 6. And we would be asserting for that. So assert 6 for the sum, and if it's the case, then the test case is passing. If there would be something else, or if we encounter some exception, the test case would start failing. Now this is pretty trivial. Hopefully it kind of makes sense how this is being done. Now this code can run on mainframe. Java can run on mainframe. But Java is not the most prevalent language on the mainframe. The one that is most prevalent is COBOL. So how you can write something like that for COBOL code? Let's take a look. And let's start with some example in here. I do have here partially code of something that I call utility function. And this utility function, essentially, it's a COBOL module that computes Fibonacci numbers for a given sequence number. So in the procedure division, you see that you have a input parameter that is actually the sequence number that I want to get the Fibonacci, and the results will be returned in the Fib results. That is the output parameter. And in the procedure division, there is one section being called that essentially sets up the base numbers for the Fibonacci. So essentially for the sequence 0, the Fibonacci number is 0. For sequence 1, the Fibonacci is 1. And then the next Fibonacci numbers are always sum up of the two prior numbers, and that's what is being done in the calculation. So I essentially perform a loop in here that counts down towards 0 for the sequence number that we are calling, and this is actually being done in the next Fibonacci number to get that next sequence number and get to the final result. Now, I could start writing unit test cases for the individual paragraphs, but for simplicity, let's kind of test this whole CSEG or this whole module. How a unit test case might look like, it's something like this. So in here, you see a COBOL code. It's a pure COBOL code. There is no preprocessing needed, and it leverages a testing framework. That testing framework is actually called Test4Z, but let's focus on the concept in here. So in the procedure division of a COBOL, what I have in here is that I do registration of a test case. So these 4 lines actually instruct the test framework to register a new test case. The new test case is my Fib test 1. I can have some meaningful description for the test case, and then I just call the framework, hey, register this test case. The body of the test case itself starts at the myFib entry. And the things that you do in here is that first you need to tell the test case what you're actually testing. So you need to tell this is the module, so prepare the module for me. And the test framework will grab this module, which is the utility function that computes Fibonacci numbers and prepares the module in memory. Once it's in memory, we need to get some addressability into that module. And so there is another API. These are actually called test APIs as part of the test framework. And the function or the API in here is get function. And I'm getting a function pointer to the beginning of the module. If there would be CSEGs, I can also provide the respective CSEGs by just moving them into the CSEGs names. And the my function pointer will be filled with the entry point to the utility function. And then, well, you can start initiating the test case. So similarly as in the Java example, I provide some input parameters. In my case, I just want to get Fibonacci number for sequence 8. So I move it to the Fib end variable and call the function pointer, which points to the utility function, and it performs it. It runs, and once it finishes, now it's time to do some assertions. In this case, the assertions are done simply by calling COBOL statements. I'm doing if. So if the return is not 21, because this is the Fibonacci number for sequence 8, then I want to fail the test case. And failing of the test case is again done by calling to the test framework API, and I can provide some meaningful message why the test case has failed. So this is how you can write a test case with the test framework that I mentioned, Test4Z. And now how to run that? You would run it very similarly as actually one more thing before I go into how to run it. The question in here is, do I have to write all the code? So COBOL as such, it's rather a chatty language. And as I mentioned, the test case on the prior slide was written in pure COBOL, so there is no extension. And as you probably know, COBOL is hard to extend. So unless you are IBM, it's hard to extend the language, at least when we're talking about the enterprise COBOL. In the latest version, there are possibilities to register user functions. but that would require one of the latest compilers, and it still doesn't give you the ability to extend the language similarly as for example in Java. But going into the question, like, do I have to write all the code? Yes, you need to write the unit test case code, and as such, the unit test case code is part or is extending your application code. So it should be sitting alongside of your application, and you should treat it in this way. One additional pointer or look at is that the test case actually even serves as a documentation because it describes how your application behaves. However, you do not necessarily like need to write each line. And if you are using Visual Studio Code, and this is the screen print from Visual Studio Code in here, you can leverage so-called snippets in writing your code. So as you can see here, I've added I've registered one more test case, the second test case that would be testing 42. And I can start writing the entry. And as I type to do the prepare module, the snippets are suggesting, okay, this is what you should write. And if I select this one, it will give me the lines for registering and preparing the module. So this would make your life a little bit easier. Now, going to what I was about to say, how to run the test case, the test framework.
Sorry.
Yes,
Petter?
please.
Yeah. So to be clear, for me, you are just writing a COBOL program to execute via test for Z, correct? So at some point this will actually get compiled. Is that right? You know,
that's correct.
Okay, and I love the fact that I was going to say, is there any chance that you could get the autocomplete for these things? But you've already answered that one. So.
Perfect.
It looks like the learning curve for this isn't incredibly steep if you're already a COBOL programmer and you're using an editor under VS Code, correct?
That is absolutely correct. And so essentially, if you are using VS Code, you have the luxury of using these snippets, which would hopefully make your life much easier. But nothing prevents you to use ISPF, right? So if you want to write this code in ISPF, you can surely do so, but you would be missing on these cool things that are coming from VS Code.
Okay, thanks.
And thanks also for pointing out how to run that. I'll get into in a moment into the compilation, and actually let's jump into it straight away. So. How to run that? The framework, the test4z framework, actually has a command line. It nicely integrates also into Visual Studio Code, but I want to show you the command line. So essentially, I just like call the T4Z from my laptop, say what test case I want to run, and it would actually execute. The command line would make sure that it synchronizes, it builds not only the test case but also your application if you would want to build it, and then essentially run it. This is kind of similar to how you would run your test cases for Java code, right? So you just say Java and run this test case, and that would be it. For the mainframe, it's slightly challenging because you want to run and exercise the test cases on the mainframe. So if you are leveraging VS Code on your client, you need to make sure you get that code, the test cases to the mainframe, builds it there and run it. So a test case, similarly as in Java, is really an executable. Now, as part of running the test case, if you ask for that, also code coverage is being captured, which is a good I'd say like lagging indicator or leading indicator to how you do with your testing. In this screenshot in here, you see that these green lines, green vertical bars, denote that the code has been fully tested, 100% tested, because this is a really straightforward execution. And if you can use it to kind of measure how good job you are doing with testing, and if there are some other areas that you should focus and write unit tests for. Now let's take this to.
Sorry, can I keep asking
Please.
questions?
Absolutely.
So Petter, I came from a retail bank, And one of the things that we had to do as part of our change process was at the conclusion of testing, we had to attach the test evidence to the change record. So from that screenshot, sysout.txt has been put somewhere. Is that in USS, or has it been put on my workstation, or what? Where's the output go?
So the output is obviously in the jobs pool. Or the framework takes it and puts it into the Unix system services workspace that is actually needed. However, it's also been taken and it's on your client. So if you are using client, this is actually the folder that is respective to this Fibonacci folder. So you can go and you can view it either in VS Code or grab it. And there's actually. Please.
I'd simply be able to either drag and drop or get that output, assuming that my code coverage is I've tested what I've changed. I'd just be able to put that onto my change record and I'd be good to go. Yeah, simple as that.
Absolutely.
Beautiful.
Yes. I'll give you a little bit more color since you've asked. So essentially, these ZL message are essentially messages from the test framework. This is helpful if something goes wrong. You can take a look. Sysout obviously is what was produced as part of running the jobs under the test cases or the programs under the test cases. But you can provide additional evidence. So in the output of the CLI here, you see that the test case passed, how long it took. You can also instruct the CLI itself, hey, produce the test record evidence for me in a form of junit.xml. So junit.xml format is the de facto standard for reporting on running unit test cases. And you can ask for it. I don't remember what is the exact syntax, but it's something like --junit XML report, and it will be generated for you. So then you can grab it, you can put it as part of your change management tooling, or put it into have it as part of your pipeline, store it in there. In addition, the same can be done for code coverage. So if you ask code coverage, the code coverage metrics is actually being synchronized to the workspace in my client space as well. And we actually provide, or the framework provides multiple formats that are being recognized as a standard format. So Globetura, Clover, those are some of the XML or JSON formats that you can easily grab. And so, for example, if you do code scanning using, let's say, SonarQube, you can grab some of those outputs from code coverage and make it part of that scanning as well. So you would also see the code coverage in that tooling.
Fantastic, thanks.
Thank you very much for the questions. I'll move us on. Okay. So I know that when you explain things on a simplistic cases, it kind of makes sense. But then when it comes to the real world, you might start facing some challenges. And the like biggest challenge on the mainframe, from what I've seen, is that usually is the data. The mainframe programs or mainframe is running the world, and that's where the heavy data processing happens. So I want to now take it to kind of a next level, the sample that I've shown you, and how you can prepare for the testing and mocking with the bigger data. Again, for the simplicity, this does not really reflect reality, but hopefully you see the analogy that I'm trying to drive in here. So I talked at the beginning at the utility function that computes Fibonacci numbers. In here, I do have a driver program that actually drives the execution and calls the Fibonacci number. What it really does, it opens an input file, reads line by line, and the records that are being read in are actually numbers, and those numbers would be passed into the utility function. And I want to get for the sequence number, I want to get the computation of a Fibonacci. Once I have that, I'll just grab the sequence number as well as the Fibonacci results, and I write it into the output file. Now, to better illustrate that, I think it might be nice to see it in form of a JCL. So this is the driver program. It comes from this log library. For the simplicity, I have the sysin input data set in stream in the JCL, and you see it has 11 records. And for those 11 records, I would want the Fibonacci to be computed, and the output is being placed into sysout. Now, as I mentioned, the challenge on the mainframe is with like grabbing the data for your testing. And you can use the test4z framework, the test framework, to kind of drive the execution of the driver to collect and do a recording. So in place of the driver program, I'm just calling ztest.exe, which is the framework utility to collect or to do the recording. I need to obviously provide the load libraries and say, okay, this is where the data will be stored, the recording, and I instruct, hey, call the original driver program. What this will do, it will do a recording. However, it will not do, if you are thinking about screen capturing or something like that, it doesn't do screen capturing. More so, this is a batch job, so it's probably obvious. But I wanted to stress out that this is not really like screen capturing, but rather it records program to program and program to data interactions. So how such a recording might look like? It's not a binary dump. It's something that you can actually read. So it's in a JSON format, and this is a portion of the recording that can be produced. If you would kind of scan through that, you see that there was a read recognized on the sysin. The data that was read, it was the initial record, which was 0. For the 0, the utility function was called, and as part of the recording, the framework captured the values of the parameters before the call and even after the call. In here, you see only zeros. That's because the input the sequence 0 is 0 Fibonacci. And so once I get that, I output it, or the recording captures that it was written into the output file. Now, what to do with this? You can use it and feed it into a unit test case. So this structure by now should be somewhat familiar. There is one thing that is that you haven't seen today yet, but let me quickly walk you through that. So in the procedure division, again, I'm registering the test case, and then the test case itself starts at this entry point. You've seen the prepare module already, which prepares the driver program to be tested. And I'm getting a function pointer to the driver program and simply calling it. The one thing that you haven't seen before is this create harness API. And what it does is it takes the JSON recording, and out of the JSON recording creates mocks for all the objects that have been recorded. By default, the mocks are being created for files, DB2, but it's not by default for program to program. So essentially, for this particular case, the input data set is fully mocked, and the output data set has a mock instance. So essentially, the program program under test will be able to write to it, and we can do even some inspection. The thing about this test case is that it doesn't test anything. So if I would want to add some conditions and to make sure that this is testing, so for example, I can test for things like was 11 records processed? Yes, then this test case is okay. In other cases, just failed test case. But why even this test case would be important for me is that this test case is driving my program under test that I'm about to update or do some changes. And I can run this test case how many times, whenever I want. So essentially, this test case all of a sudden created an environment for me that I can reuse and repeat as part of my development process. So the thing here is that even one simple test case, unit test case, can help you speed up of your development process, because all of a sudden you do not need to go back and reset your data, provide some new inputs, make sure that the shared data are the same, make sure that the shared resources are in there. You do not need to do that, because everything was previously recorded, and it's part of the test case created through the Test Harness API. And as you go, as you put your changes to the program, and as you start adding more and more functionality, you will be also extending the test case, and all of a sudden you are building your unit test base that would then, from a long run perspective, will build the safety network of your test cases for the whole application. And that's the main point that I want to drive in today, is that even with a very simplistic individual one test case, you can speed up your development as you can then rerun it repeatedly. Okay, I think we're heading to the end. So I've introduced you some of the concepts, how you can write a unit test case for a couple programs. If you would want to know more, please drop me a message. I'll be more than happy to chat through that. This is my favorite topic to talk about. And if you would want to also check some of the materials on the framework, Test4Z framework, test4z.broadcom.com is available. I know that Stuart was asking question. Thank you very much for that. But before we kind of go into this question answer mode, I want to ask you for feedback, right? So either on the side GS UK, click the link, or use this link with the 4K. You can even use the QR code. If you like the session, please let me know. If there are things that you didn't like, please say explicitly so I can improve next time. And also, this is a good feedback for the GSE to make sure that we're hitting on the right topics as part of all the sessions. With that, I'm happy to take any questions. So what questions do you have?
So as a selfish GSE app dev track person, Petter, I'm going to say that, last year you did a great job at Broadcom of having workshops with VS Code in the room. Do you think you'd be able to concoct a Test4Z workshop, for the in-person conference to give people a hands-on experience for this?
Okay, thank you for this offer. I hope you have the slot for me, because yes, we can do that.
Definitely, it's already reserved. I can see the room now.
Perfect.
So that's good. And the source code, is there a best practice? Do you keep the test program in your same version control as you would the source code? Would you give it a different type name or any kind of things like that you've seen with customers?
So it might depend, but essentially you should distinguish either by the name. So essentially the name denotes that this is a test case and this is an application, or you can have a different type, and this would also depend on what source control management you're using, right? So let's say I know Endeavor from my past experience. So in Endeavor you would define a new type that would be a type of a test. If you are in Git, you would most likely either use the extension, or you would probably even leverage the project structure. So you would have a different folder for test cases that would be correlating to your application sources. But definitely, and that's the most important thing, is that the test cases needs to be part of your version control alongside of your application, because as I mentioned, the test cases are really extension of your business application, and you should treat it as such.
Fantastic. It's exciting. The more options that mainframe engineers have around automated unit testing, I think the better, because it's still a much overlooked part of the software delivery lifecycle, I believe, automated unit testing anyway.
Yeah, on the mainframe, lots of the testing even these days is done manually from like my own chats with clients and mainframe people. It's probably half and half, maybe even a bigger half, not being automated. And even for the things that are automated, those are in my experience semi-automated. So someone needs to trigger it. Sometimes someone needs to interpret the results, and that's not what you really want from unit tests. You want to have, as I mentioned, a safety network of automated runnable test cases that will tell you at any point in time, hey, something's wrong, or yeah, you're good and good to push to production. Also, I know that I'm not like saying like, yeah, you need to automate, right? Unit test cases. But the bottom line here is that really any testing is good, right? As I mentioned, the mainframe programs and mainframes are running the world. Our bank accounts are being managed through the mainframe code. So any testing is good, right? Because when it comes to money and when it comes to our things, we want to make sure that there is a good quality.
Fantastic.
Okie dokie. Do we have any question? Anything
No,
that I thought?
Nothing in the chat, and I had asked a couple of times, so no. But I still found it very insightful. Thank you, Petter. As I say, looking forward to hearing more, and maybe even you can persuade a customer in November to come along and extol the value of automated unit testing.
That's for sure something to consider. Absolutely.
Great.
Okay, so if no other things to chat through, then thank you very much. Thank you very much for the questions, Stuart. Thank you very much all who participated. If someone's watching from the recording, then in case of any questions, my email address was mentioned up there, so feel free to reach out to me. Thank you very much. Have a great day.
Thank you. Bye-bye for now.